Hello everyone, I hope that you are doing well. Until here, we have learned how to install VMware, how to install, configure, build NS3 and test the first code. Okay, at this point it is the time to start programming and writing topology and simulate it. Okay, if you don't know how to install and how to run NS3, I highly recommend to watch previous videos. Okay, there are some very useful files in the examples tutorial folder. They are teaching programming in NS step by step, that we are going to analyze them in detail. If you finish watching the videos about all the files, you will have knowledge of programming and defining different topologies and different networks. The first file that we are going to have a look is called, first, if you look at the file, the first lines are some comments about the license and some other things that you can skip them easily. Okay, the second part is about including some files. For working with NS, having a basic knowledge of C++ is essential. You should have some knowledge, then you can start. Okay, if you have a C++, if you have some C++ knowledge, you know what including is, and you know what point H files are. Okay, but in case that you want to see where the including files are, you can go to NS3 and you can go to build, you can go to NS3. Over there you can see the headers. Okay, but they are not, it is not important to exactly know how they work, just we should know when which headers should be included. Okay, let's go back to our file and analyze it step by step. The second part of the file is the topology of the network. In this network we have two nodes, N0 and 1. N0 is the client and it is going to send a packet to N1. N1 is a server and it is going to echo the packet. The network IP is 10.1.1.0. Okay, so both of the nodes are in the same network and they are having the same network IP, and the protocol for connecting them is point to point. We are going to use a wired channel and it is going to be used as the transmission media. Okay, the next line using the namespace NS3 is for defining NS3 namespace. If you are familiar with C++, and you should be familiar, after defining this line we don't need to write NS3 : before each NS3 commands. Okay, and the next one is for defining a log component and naming it as first script example. Okay, this is for the console messaging and it will be useful, you will see in the future. Okay, until here it was the definition. After this part in main, like a C++ program, the main program is going to start. The first line, time set resolution, is for defining the resolution time and it is going to be nanosecond. It is the default one. Okay, we don't need to write this, or if you want to change the resolution time, okay, you can use this command. The next two lines are for defining log components, one of them for the client and the other one for the server, so we can send the messages of them, exactly the events messages, to the console. For example, when a packet is received, when a packet is sent, and blah blah. From this point, the main body of the topology is going to start. Node container nodes, node create. These two lines are for creating two nodes. But how? First, we create an object of node container class or node container helper. Then by using the create method of node container and putting the number of the nodes, we create nodes. How many nodes? 2. Here I'm going to show you how to get information about classes in NS3 and how to get information about the classes methods. Okay, if you learn this procedure, it is going to serve you as a lifetime rescuer. It will help you as long as you are working with NS3. For this, you should go to NS3 website. Okay, this is the NS3 website. Then go to the documentation. Here, because we are working on the latest release, okay, we go to the latest release section. And here you should go to API documentation. Here. Okay, I click and go over there. In this part, you should go to classes because we want to know about classes and the methods. Okay, I open the classes and then class list, and over there NS3. So classes, class list. Okay, what are we looking? The classes in NS3. So NS3. Over there you can see a lot of classes that NS3 includes. Okay, you can click on them and see the information about it. But what class we are looking for? Node container. So we go to N and find node container here. If you click on it, it goes to the node container part with some explanations. Okay, if you click on more, you can see the description of the class. Keep track of a set of node pointers. Okay, it means that if you read it, there are some more information. Okay, they are useful. It means that this class, this helper, creates nodes and keep their pointers, so we can use them. Now, if you want to see a method of the class, you can search here, over here. Okay, or easily you can open node container. Okay, scroll down and find create, because okay, we are looking for create method. So okay, create n nodes and append pointers to them to the end of this. Okay, blah blah. As I said, create is creating a number of nodes and keep pointers for them. So it is an easy way to go to NS3 documentation, to go to the list of the classes and see how a class works. And more importantly, you can see each method explanation over there. So in a nutshell, here we create node, an object of node container. Then by using create method, we create two nodes. Okay, after this part we have two nodes. Now we should connect these two nodes. How do we connect them? Here we are going to use point-to-point helper. This is for connecting nodes directly to each other. Okay, again, we define the point-to-point object, and we are going to use it. Again, if you want to see how this class work, you can go to the list, and over there you can find point-to-point helper. Okay, let me find it. Point-to-point helper here. Okay, again, if you click on more, you can see the explanation. Build a set of point-to-point net device object. So it's for connecting the different nodes together. Then the next line, we are going to use point-to-point and define some attributes. In a real network, we have network cards and we have channels. Okay, they are going to be used for creating the network. Device over here is a representative of network cards, and channel is for channel. Attributes are features that we can change, we can set them. For example, for the network card, for the device, we can set the data rate. As an example here, it is 5 megabit per second. We can change it to any number that we want. Okay, so from the set device attribute, we can change the data rate and choose the value that we want. Again, if you want to see different attributes, you can go here, point-to-point net device. It is the one that we are using in our code. Okay, net device. Again, click on more, you can see the explanation, and if you scroll down, you can see the attributes: MTU, address, and data rate. The default data rate for point-to-point links. It means that it is going to determine the data rate. The next attribute is for the channel, and it is delay. It is the delay of the channel. So after data rate, we set the delay for the channel, and we can set it to any value that we want. Okay, until here, we have created our nodes, 2 nodes. We connected them by using a 5 megabit per second link with a delay of 2 milliseconds. So what is the next step? The next step is to install the point-to-point on the nodes that we have. If you look at this line, install nodes. Okay, install method is from the point-to-point, and point-to-point is going to install on the nodes. Okay, after installing, we put them in a net device container. A net device container is for keeping our devices. So we created 2 nodes, we installed the point-to-point on them. So where to keep them? In a net device container. Okay, but our net device doesn't include any protocols, UDP, TCP, IP. Okay, for including them, we use Internet Stack Helper. In NS, this is for protocol stack. So we define an object, then by using install method, like the previous install from point-to-point helper, we install the protocol stack on the nodes. So we have until here we have device, nodes, and the things that we need, and everything is ready to connect to nodes. But without IPs, it is not possible to connect to nodes. It is not possible to have communication. So what is the next step? The next step is defining the IP. For defining IP, we should define the base IP. For example, 10.1.1.0. It is the base IP. Then assign them to the nodes, and they are going to be sequential. The first node is going to be 10.1.1.1, the second 10.1.1.2, the third 10.1.1.3, and so on and so forth. So for this, from the IPv4 address helper, which is for assigning IP and creating IP, we create an object, and set the base IP to 10.1.1.0 with the network IP of 255.255.255.0. Okay. After that, we assign them to the devices. Okay, the devices that we created here, and put them in an interface. How do we define the interface object? By using IP4 interface container. This container is for keeping the interfaces that we have created until here. Nodes, point to point on them, then stack protocol, protocol stack, then the IP. All of them together could create our nodes, and these nodes are in the interfaces object. So let's have a quick review. We have created two nodes. We have created a point to point with a 5 megabit per second data rate and 2 millisecond delay. Then we installed the point to point on the nodes and put them in a net device container. After that, we created the protocol stack and installed them on the nodes. Then we defined the base IP, so assign them to the devices and kept them in an interface container until we have all of the things that we need, the protocols and everything. Now we need to define the applications and put them on the nodes. So by the help of the UDP EcoServer helper, we define a UDP base application for the server. If you look, we create an object and we write 9 inside the parentheses. That it is saying that the server is going to listen on port 9. Okay, then we install this object on the node. Which node? Okay, if you look, this is the node. Okay, we defined here. So we get the number 1. So it means the second node, because it is starting from 0, 0, 1. Okay, we choose the second node, install the application on it, and keep it in an application container like the previous thing that we were keeping in the containers. Then we say that the application starts in the first second and ends in the 10th second. This is a double number, so we cast it by using seconds to the NS time. So defining the application starting time and ending time. There is a similar situation to the client side. We use UDP Eco Client Helper to create an object. The first parameter of this object is the remote servers determination. So which node the client is going to send the data. Okay, from the interface we get address of the second node 0, 1. Okay, this is the targeted node. The second values for the port. Okay, port 9, both of them should have the same port. Okay, the others are defining the attributes for the client side. Max packets, it is the number of the maximum number of the packets that the client is going to send. If it is 1, okay, it is going to send 1 packet. If it is 2, it is going to send 2, and blah blah. Interval is the time between the packets. So when it is 1 second, it means the time between the packets are 1. And packet size is the size for the packet. Okay, that's clear from the name. Then, like the previous procedures, we install the object on the node. Which node? The first node, because it is 0, so the first node, and put it in a container, because it is an application, so application container. And again, we are going to start at time second. They are arbitrary, but okay, we should have some logical connections. The server is going to start at 1. Okay, after that the client is going to send. The client is going to stop at 10. And the last lines are for running. When you run simulator run, the events are going to be run sequentially. For example, here this one, after that this one, and these two at the same time. And when the simulation is finished, this row is for cleaning up the simulation. Now we are going to run this code. What is the first step? We are going to copy it to the Scratch folder. So we go to Examples, Tutorial, first copy, Scratch, paste. So we run terminal. We go to NS3 folder. Okay. If you remember, I've told you for running a program we use /wav --run /run, which folder? Scratch folder. Which file? First, and we delete the suffix. Now we are going to see the results that is going to be logged to the console. Okay, if you look here at time 2, the client sent 1024 bytes to the destination. What is the IP of the destination? Okay, if you remember, 10.112 and port 9. Okay, which line? This line. Okay, application of the client starts here. Then at time approximately after this time, the server receives the bytes. Okay. After that, server echoes the received packet, so it is going to send 1024 bytes to the source. So this is the IP, and the client side is going to receive the packet. So client sends, server receives, server echoes, client receives. We can change the attributes of the client and see the results, but for this we should go to the Scratch folder, open first, and for example we can increase the number of packets to 2 and see what happens. Okay, if you see, the logging message is different. Okay, here we have 2 packets that have been sent and echoed. So here we are, the first code is finished. Okay, it was a topology with 2 nodes and point-to-point communication. So in the next video we are going to expand our knowledge of NS3 programming.